Hey, hello everyone. In this video, I introduce you the solution for LeetCode weekly contest 343. There are 4 problems. The difficulty is 3, 4, 5, 6. So we go through the problems one by one. First, this is the easiest problem in this contest. So it's just the problem is like there are 2 players. They play a game, and there are n turns for the game. That each player has n turns. That for each turn, the points is 10. The total point is 10, but the player can earn any points, like from 0 to 10 in each turn. And the score is like, if this player hit 10 points in the previous any of the previous 2 turns, then this turn's score will be doubled. Otherwise, it's just this turn's score. So the output is the problem is want us to calculate the total score of each player, and if player 1 is more than player 2, then output 1. And if player 2 is more than player 1, then output 2, otherwise output 0. So the problem is really, the solution is a quite direct solution. Like here, we just calculate the score of each player. So for this for loop, we just check whether this player hit 10 in any of the previous 2 turns. If it is, then we double the score in this turn. Otherwise, we just add the current turn score to the answer. And here we just output like the requirement of this problem, like output 1, output 2, output 0. So this is quite a direct solution. Next problem. For this problem, it looks like we may have actually one array and also have another matrix. And these array's elements are equal for all of the elements in the matrix. And the problem is like it wants us to paint this matrix cell based on the order of the array. Just for example, this array is 1, 3, 4, 2. And this matrix looks like this, 1, 4, 2, 3. And then first element is 1 in the array, and then we paint this the corresponding cell with the value 1 in the matrix. And the next 3, then we paint this 3 here. And 4, then we paint 4. And until if there is a row or if there is a column, like all of its cells are painted, then we output the index of the array. So just like the first example, that after we paint cell 4 here, that we have a row here and also a column here, and all of its cells are painted, then the output is index of 4. So this is 2 based on 0 at 0, 1, 2. So we output 2 here. Okay, so for this problem, the solution actually can also be very direct, very simple. It's like, so here I calculate how many rows we have, how many columns we have for the matrix. And for each column, for each row, I create a side for them. Like for each column, for each row, I create a side and store this side in a vector. And here, for each element, I calculate like each position and store it in this vector. It's like for elements 1, the position is 0, 0, and element 4, the position is 0, 1. It looks like this. And in these 2 for loops, I just construct this each rows and each columns vector. each rows and each columns set here, I just insert the elements into the corresponding sites. And also I construct this array, like for each element, I store its position here. And the next one, I just iterate this array's elements. And for each iteration, I just erase the elements from its size, from its rows size, and from its column size. And then I check whether the column is empty or the column, whether the row is empty or whether the column is empty. If it is, then I output the index. So this is for the second problem. Next one, we go to the third one. So for this one, it's a little complex. So I just maybe, other than reading this problem, I may introduce you directly on this graph. So here, we may get a start point here. And we also have a target point here, right? So this is the start. This is the target. Our target is we want to go from start pointer to the target point. And the length of this road is calculated like this one, like x, the absolute value x, x2 minus x1 plus absolute value y2 minus y1. So this is the length. And this problem, like there are several special rows like this. And also maybe we have another special rows like this. And for each special rows, we are provided a special rows cost. And also this rows also has its cost. And what we can do is we can also from this start pointer to this to one special rows start pointer, and then from special rows go to its target pointer, and from here we can go to the target pointer, or we can also from here go to another special rows start pointer, and then from here we go to the target pointer, and then here we may go to the target pointer, or maybe from here we can go to another special rows start pointer, something like this. So we are asked what is the smallest cost from start point to the target pointer, that we can make use 0 or any number of special rows. Okay, so for this one, actually it's a little complex, but it's also very direct. So what I'm doing here is like I have a map to so this map is go to store the for each special rows target pointer. What is the smallest cost from start pointer to this special rows target point now? What is the smallest cost? Okay, and here I initiate the answer to be the normal cost from start pointer to the target pointer. And here in this for loop, I just calculate the each special rows target pointer current smallest cost, just based on from the start pointer to each current target pointer. So that is the normal cost. Which what I mean is I don't make use of these special rows, but just calculate from this pointer to this pointer. Use the normal cost. What is the normal cost from here to here for each target pointer of the special rows? And here I create a state of the position, like this one is for for each of these pointer, if its cost is reduced, then I store this pointer into this side. And in this for loop, right, I just check for each special rows. And so here I may go from start pointer to this special rows start pointer and make use this special rows cost here. I calculate what is the cost now, that if I make use of these special rows, and if this cost is smaller than the current cost, so I will, here I will store this special rows target pointer into this side, and also for each iteration, I update the shortest value in this map, and also I update the answer. So what I'm doing here is like this. So here I have a map, right? So I have a map. This map is like a from each special rows target pointer, and the current smallest cost it may have, right? So here I update this map and also update answer, like from this start pointer to the current special rows target pointer, and then from here I go to the final target pointer. I update this length if this is shorter than the current cost. Okay, and the next one, I just check whether this set is empty or not. If it is not empty, then we just get the first element from this set, and from here I iterate all of the special rows to see whether I can update the smallest cost and also final answer, and also like if I can get a smaller cost to any special rows target pointer here, I also store it here. So this just like this for loop, but it's not from start pointer to here, but it's from this pointer. If this cost is reduced, so I just check from this pointer to all of the other special rows to see whether I can reduce the cost to reduce any of the special rows target pointer. If this is reduced, then I also update the final answer, make use of the current smallest pointer, the smallest cost, update the final answer, and update this map, and also store this pointer to this side. So finally, this set will be empty. Then output the answer. Okay, so this is the solution for the third problem. And the next one, this is the last problem. So let me try to introduce what these problems means, other than reading the problem. I may introduce you directly. So for this one, that we may have a string. What about string? So this string means this string length of n. So there are n characters in this string. And first of all, we may say what we call string is beautiful. That if this string consists of only the first k letters of the English lowercase alphabet. And secondly, it doesn't contain any substring of length 2 or more, which is a palindrome that we call this string is beautiful. Okay, and so for this problem, we already have a string that is a beautiful string, and also we are given the case value, and our output should be the next string that is it's let's say congraphically smallest string of length n that is larger than s. So it's much larger than the current string, and but it's also for all of the string that can meet the requirements. This string must be let's say congraphically smallest string among all of the string meet the requirements, and also this string should be beautiful. Okay, so for this problem, how we consider the solution is like this. So first of all, we may say we have s, right? So we have s. For example, we have 4 characters, or maybe a little more. We have 6 characters here. So this is 0, this is 1, 2, 3, 4, 5. So totally we have 6 characters here. And we can see like the beautiful string, one requirement is it must be palindrome. Then so let's think about if we change the last character here, right? Because this change is based on a beautiful string. So we only need to check that for the character on position 4 is not equal with position 5. And also we need to check character on position 3 is not equal with position 5. So if we can meet these 3 conditions, actually we can say the new string is also don't have any substring that is palindrome. Why? Because all of the other parts, right? So all of this is actually we can say they are not palindrome, and the only change the character is on position 5. So that if this 5 is not equal with 3, this 5 not equal with 4, so that means this substring is also not palindrome, and also we can understand, right? So this part of string is don't have any substring of palindrome because s is beautiful. So actually that means it's enough that we just check position 5 with position 3 and position 5 with position 4. So there's only 2 checks. And from here, what we do is we just try to increase the current positions character and check whether the new string is beautiful. That one we check whether the change the position character is equal with the previous 2 characters. One is we go to check whether this increased character is still in the limitation of k. Okay, so if this is meet the requirements, then that's okay. We already get the new string. Otherwise, we just move to the right side to try the next position at position 4 and try to build a beautiful string from the current position to its left. So we want to build a next beautiful string here. And if this we can build a beautiful string here, then from the current position, we go to build the beautiful string of length n from the current position to its right. So here we can start the character A, right? Because we already know that the substring is it's max it's let's say congraphically bigger than the original string. So the new string on the right side will be it can start from A and it's from A to A plus k minus 1. So we can go to build this. Okay, so This is the code. Here the method is check valid. The valid means this is the new characters and the new characters position, and then I just check whether this position is -1, or if it's bigger than 1, then the new character must not equal with the previous character, and same like whether position is -2 or the position the current character must not equal with the previous 2 positions. So if it can meet this condition, we call this character is a valid character. And here I just iterate this string from the last one to the first one. And for each position, I just go to increase the current character until it go to the limitation by k. And if this is valid, okay, so I just update this string's positions character to be the new one. And here I construct the new string from the current position to its right. And I start from A and check whether that is valid. If it is valid, I just update the position here and also break the current for loop and go to construct the next position's character. And finally, after the new string is constructed, I return the new string. Otherwise, if this for loop I didn't return here, that means I cannot construct a beautiful string, a new beautiful string. So I just return empty string here. Okay. So for this problem, I think the key observation is it's just like based on the current string, which is beautiful, that we only need to check 2 positions before the current position, and we try to construct a new beautiful substring at first from the current position to its left side until we construct a new beautiful substring. Then based on this new beautiful substring, we from the current position to its right side to construct the whole string of length n. So this is the general idea of this problem. Okay, guys, so this is the solutions for the LeetCode Weekly Context 343. If you have any questions, please let me know. Thank you.